The purpose of this video is to talk to you a little bit about what I expect you to provide for me in Project 1. Every time I assign you a project this semester, I'll have a conversation with you. In another video, I'm going to show you how to generate the printouts that are needed for all the projects in one spot. And I'd recommend that you guys, when you enter your data, go ahead and just create the printouts that you're going to need for the semester. That way you only have to access the software once. You get all your printouts, you put them in a Word file, you save it cleverly called something like QMB 2100 printouts for spring 2023, and then you're done with the computer part of the class in one session. So have that separate, but here's the discussion for Project 1. First, it's due on January 29th. You're probably watching this video hopefully earlier than that. Hopefully you've started a little bit before then. And you have a couple weeks maybe, or at least several days to do the project, but it probably shouldn't take you more than an hour or so once you have all your printouts generated. I want you to go through and answer the questions that I ask. However, when you answer them, words like data and variables are way too generic to get full credit. I want you to talk about prices of Brandon homes or mileages of Ford Mustangs. I want you to be as specific as you can when you answer the questions. And what I refer to that, what you hear me say, is those are the words of the problem. If I talk to somebody about data, they look at me funny. But if I talk to them about Brandon apartment rents, okay, that makes sense to them. So I want you to start getting in the habit of using the words of the problem. For instance, in your notes early in the semester, I talked about an experimental unit being the object we measure to get a single piece of data. And so when I talk about student data, a single student would be the experimental unit, and the GPA of the student would be a variable. It'd be quantitative, or the gender of the student would be a variable, and that would be qualitative. I want you to identify the experimental unit for your project, for your data. And apparently at the top you see there's only three choices, right? Automobiles, homes, apartments. The experimental unit is the object we measure, a single one. So tell me what you're working with. And then in question 2, tell me the variables. Tell me the prices, the rents, the sizes, the mileages, whatever happens to work for your data set, whatever the appropriate variables are. And the type are going to be quantitative or qualitative, and I've talked about them this semester. And then for one of the variables, your model or location variable, you have levels 1, 2, and 3, and that's how I'm having you enter them in the software. And tell me what the 1s, 2s, and 3s represent. And this is going to be something you need throughout the semester, so jot this down somewhere that you have access to. Level 1 might be Ford Mustangs. Level 2 might be Chevy Camaros. Level 3 might be Dodge Chargers. They may be Brandon Apartments, Valrico. Or level 1 might be Valrico. Level 2 might be Brandon. Level 3 might be beautiful Plant City. Guess where I live? So tell me what level 1, 2, and 3 represent. So no printouts necessary. Just tell me about the data that you're going to be working with this semester. The first printouts come into play in question 4. I'm going to ask you to create a stem and leaf display and a histogram for, and you're going to see this a lot in the projects, the sizes and the mileages. Now you only have one of those. If you're working with automobiles, you have mileages. If you're working with the apartments or the homes, you have sizes. And so give me the appropriate stem and leaf display and the histogram. Again, I'll refer you to watch the project printout video, and I'll show you step by step how to do this. I don't expect you to have any knowledge of statistics or software, but I will take you step by step through the process. And again, when you're creating the printouts for this project, go ahead and do all of them. I'm going to show you how to do all 4 projects that you're going to have this semester, and that way you'll have them on hand. And then give me an assessment. And the different shapes we're looking for at this part in the semester at least are, is the data symmetric or is it skewed? And if it's skewed, which direction? And we've talked about how it's skewed in the direction of the tail. So we talk about skewed left, skewed right, or approximately symmetric. And again, this is a great problem to think about the words. Don't tell me the data is skewed to the right. Tell me about the mileages of my 75 automobiles are skewed to the right. The sizes of my 75 apartments are skewed to the left. The sizes of my 75 homes appear to be approximately symmetric. So try to just start. It's subtle. It's not a huge statement, but it's better than data or variables. So start using the words here in question 4. So 2 printouts and an assessment of the shape that you think is correct. In question 5, I'm going to show you how to generate some descriptive statistics, things like means and medians, standard deviations, quartiles, and I'll go through again in that video, in that printout video, and show you how to do this. But I want you to interpret the mean. Now the printout you get is going to give you a value of the mean. Maybe the mean is, we're talking about prices here, so maybe the mean is $300,000 if you're working with homes. Don't just put the number $300,000 down for the mean. That's what the printout tells me. You should tell me what that mean means. Now, last semester, I think I asked for the median. So let's say the median was 300,000. An interpretation of the median would be half of the 75 home prices fell below $300,000 and half fell above. I want you to interpret the mean, and we've talked about that in some of the lectures this semester. The standard deviation, we use standard deviations to tell us where we expect data to fall. So the statement you should make for the standard deviation is we expect most of the 75 automobile or apartment or home prices, maybe call them rents, to fall between, and we've talked about how we use standard deviations to figure out where data falls. It's going to be based on the shape, so tell me what the, think about, you don't have to tell me, but think about what the shape looks like for your prices. You may have to take a look at a printout, and then tell me where you'd expect the data to fall, and I'll give you a hint. It should have something to do with 2 or 3, and I'm leaning towards 2 standard deviations. But again, refer back to the lecture where I talk about standard deviations, measures of spread, to get a better feel for that. Towards the bottom of the page, I want you to take the numbers that you see in the printout, the minimum and the maximum, and calculate a z-score. I've given you the z-score formula again in some lecture. It's the value of x, which is either going to be the minimum or the maximum, depending which one you're doing, minus the mean divided by the standard deviation. So calculate the z-score. Circle whether you believe, or bold or highlight, or do something to indicate whether you think it's an outlier or not, and tell me why or why not. And the why or why not is going to be dependent, again, upon the shape. Do you think you have most of your data within 2 standard deviations? If so, an outlier would be a z-score that falls outside plus or minus 2. Do you think that everything should fall within plus or minus 3? Then your z-score outside of plus or minus 3 would be an outlier. And so go through the process and calculate the z-score. Tell me whether you believe it's an outlier or not, and then give me your reasoning. Tell me what number you're comparing it to make that decision. And then the last printout, pretty straightforward. It's going to be a box plot. You're going to have 3 box plots in a single printout. And all I want you to do here is very simple. I just want you to tell me how many of each type of outliers. And I'm going to use words like outliers and suspect outliers in my discussion of this topic. I want you to tell me for model or location 1, I have 1 outlier and no suspect outliers. And tell me that you have no of a certain type. And you might say, I don't have any outliers or suspect outliers. But that way I know you've checked for both. If you just say I have 1 outlier, I'm not going to assume that you know you have no suspects. So you got to tell me here. And each of these, I believe, when we go to grade for location or model 1, that's a 2-point answer. And I'm going to give you a point if you identify the number of outliers correctly and the number of suspects. But again, if there's none, tell me 0. And so just tell me how many of each type. It's a very simple interpretation here. And that's it. That's what I want for project 1. Again, once you have the printouts and you have the knowledge, it shouldn't take you long to fill this thing out, but I'm going to encourage you, like I do throughout the entire semester, work early. Don't wait until the night before projects due. Work early in the semester. As you're going through the lecture material, keep current with me. So if I talk about measures of center on a particular day or in a video, if you're watching on the online class, answer the mean question right now. If you're talking about standard deviations, if I'm talking about measures of spread, answer that question as well. When I get to the outlier discussion in class, go ahead and answer that part. And if you keep current with me, it makes the class much more manageable. When you have questions, join us for office hours. If you're on the online class, you can do discussion boards. If you're in the live class, you can talk to me before or after class. Go to office hours, whether they're live for the live class or online for both classes. But get your questions answered. And good luck.